Hello students, today we are going to discuss operational amplifier. Previous lecture 2 we have discussed the characteristics of an operational amplifier and application of the operational amplifier. In application of operational amplifier we have discussed that is your non-inverting operational amplifier. Also we have discussed inverting operational amplifier and what are the basic principle of operational amplifier, what are the pin configuration of the operational amplifier. Now today we will go to the from the next slide. Already we have discussed that as an introduction what are the characteristics of an ideal operational amplifier. Particularly in ideal operational amplifier we have neglected the output impedance are 0, and since the output impedance is 0, and we have also neglected the input impedance because in characteristics of an ideal operational amplifier it is infinite. Since the input impedance is infinite, we have neglected the input impedance. So in equivalent circuit we have already discussed in case of operational amplifier, these are the pin configuration of the operational amplifier. Already we have discussed, and then there are 8 pins in a single op amp. It consists of 8 pins, and it may be your a single op amp or a dual operational amplifier. In dual operational amplifier there are 2 op amp in a single IC, and similarly quad op amp also 4 op amp in a single IC. Now pin configuration already we have discussed in the previous class. Next, that is your this is the equivalent circuit of an operational amplifier. We have discussed in previous lecture 2 how the operational amplifier can be replaced, or what are the equivalent circuit of an operational amplifier. Since it is a 2-port network, in operational amplifier it is a 2-port network. This is your input port and this is your output port. So input port can be represented by input impedance and input source. Since the input impedance is infinite, we have neglected the input impedance. It is very high, and the input is open circuited because of high input impedance. The input impedance is nothing but input resistance, that is your input voltage by input current. Similarly, the current is very negligible. Since the impedance is infinite means input current is negligible. That's why the input is open circuited here. The output port can be represented by output voltage and output resistance. So output voltage and output resistance in characteristics of an ideal operational amplifier, the output impedance is 0. Since the resistance will be 0 means there is no resistance appearing in the output, only there is a voltage source. V0 equal to A into Vi. Since the gain equal to A equal to V0 by Vi, so V0 equal to A into Vi. Already we have discussed in the lecture note 2. Next we have already discussed this is your inverting amplifier and non-inverting amplifier. In inverting amplifier the gain is what? There is a 180-degree phase shift between input and output. So this is your input voltage, the waveform of the input, and this is output. Because input and output there will be 180-degree phase difference between input and output. In case of a non-inverting amplifier, there is no phase difference between V0 and Vi. The same voltage, whatever the input voltage, similarly the amplifier, it will be amplified of the input, but the phase difference will be 0 in case of non-inverting operational amplifier. Next we have already discussed that is your what? These are the some principle of the operational amplifier. So how to design an electronic circuit with the help of cookbook. Cookbook means what? There are some designing book which contains the number of specifications of different electronic components. Using the code book we can find out the specification of the electronics equipments. So then we have already discussed the non-inverting amplifier. Non-inverting amplifier gain is your V0 equal to Vi, that is your R1 plus R2 by R2. So or gain equal to, we can say that is your G equal to, that is your 1 plus R2 by 1 plus R1 by R2, 1 plus R1 by R2 into the gain equal to like this. So R1 by R2 plus 1. This is nothing but your gain of non-inverting operational amplifier. So that is gain is nothing but what? That is your V0 by Vi. That is your output voltage by input voltage. So the gain is positive means what? There will be no phase difference between output voltage and input voltage. Then, and this is your design, how to design a non-inverting operational amplifier. As far as design is concerned, if it is non-inverting means what? You are applying the input voltage to the non-inverting terminal, that is your plus terminal, and here there is a R1 and this is your R2. This is your 1 plus R1 by R2 is nothing but your gain. In case of, already we have discussed in the previous class. Then is your inverting amplifier. In inverting amplifier already I have discussed in the previous class what is inverting amplifier. If an inverting amplifier, we are giving the input voltage to the inverting terminal, that is your negative terminal. Here R1 is nothing but your feedback resistors. First of all, you identify which resistance my feedback resistance. What is feedback? Feedback means some fraction of the output is injected to the input is nothing but feedback. So that is, this is your output and this is your input. The output is connected to the input. This resistance, we can say that this is your what? This is your feedback resistor. This is your feedback resistor. In feedback resistor here, that is your what? This is your R1 is your feedback resistor. So already we have discussed in the lecture 1 inverting amplifier. So here already I told you in the virtual ground concept, the plus terminal is grounded here. Plus terminal grounded means it is a 0 volt. If this is 0 volt and this voltage is 0, because this difference must be what? That is your 0 volt. This is the beauty of the operational amplifier. The gain is infinite. If the gain is infinite means what? The gain A equal to infinity is equal to V0 by Vi. So gain is infinite means this term will be 0. This term is nothing but what? That is your Vi. If Vi is 0, the gain will be infinite. Whatever this value is same value is like this. If it is 2 volt, this potential must be 2 volt. In this case, already we have discussed how to find out the gain of the inverting operational amplifier. The gain is nothing but what? If you are applying KCL here, there is your current I1 let and this is your current I2. Again, I will reminding. So this potential let V minus, if I1 equal to I2, if you are applying KCL at this point, apply KCL, apply Kirchhoff's current law at V minus terminal here. So that is your what? I1 incoming current here, I2 is your outgoing current. So I1 equal to I2. I1 equal to I2. What is the value of I1? I current is nothing but voltage by resistance. What is voltage? Potential across this point, potential across this point. The potential across this point is your Vi, potential across this point is 0. So that's why Vi minus 0 divided by that is your R2, which equal to out I2. What is the value of I2? Voltage by resistance. Voltage, this potential is your 0, this potential is your V0, this potential is your what? V0. So 0 minus V0 by R1, that is your 0 minus V0 by R1. Okay, so that value is Vi by R2 equal to V0 by R1. So Vi by, so that is from this equation, Vi by R2 equal to, that is your what? Minus V0 by R1, or V0 equal to how much? Minus R1 by R2 whole into Vi. So this is the expression of the output of the operational amplifier. So output voltage V0 equal to minus R1 by R2. Remember that most of the book you will find there is your feedback. This is your feedback resistor, and this is your RF. Maybe this is your RF or maybe R2 like this. Whatever the feedback resistance, here the feedback resistor is R1. That's your minus R1 by R2, or V0 equal to minus R1 by R2 into Vi. The output voltage V0 here. So V0 equal to minus this by this resistor, equal to minus R1 by R2 whole into what? That is your Vi. Okay, or V0 by Vi, that is your gain. So gain G equal to, or we may say AV equal to V0 by Vi equal to what? Minus R1 by R2. It is very, very important. The gain of the inverting amplifier, that is your minus R1 by R2. Means what? Minus of the feedback resistor, whatever the value of feedback resistor, R1 by R2. Already we have discussed in the lecture 1 of operational amplifier. So inverting amplifier gain is your minus R1 by R2. Gain of the non-inverting amplifier, that is your 1 plus R1 by R2. Remember that R1 is the feedback resistor. This value must be the feedback resistor, that is your R1. In case of inverting, minus this resistor by this resistor. In case of non-inverting, 1 plus R1 by R2. So this is all about your what? The inverting amplifier. Then if I will say, suppose there is a question like this, so that is your what? In operational amplifier, suppose this is your in case of operational amplifier, Suppose if I will give the circuit like this, suppose this is your inverting amplifier. The inverting amplifier means negative terminal here. Negative terminal is your let I can say this is your VI. So let the resistance value is your 25 kilo ohm. Let this is your 5 kilo ohm. Suppose like this. This is your minus and this is your plus. This is your plus. Let this is your V0. So this is your 100 kilo ohm. And this is your 25 kilo ohm. This is your 150 kilo ohm. This is your 50 kilo ohm. Okay. Find V0 by Vi. The question is find V0 by Vi means what? Gain. So V0 is here and Vi is here. You have to find out the voltage gain V0 by Vi. Okay. What you will do? First of all, this is your op-amp 1, this is your op-amp 2, and this is your op-amp 3. There are 3 op-amps. Clearly this is an inverting amplifier. Already I told you, inverting amplifier means what? You are giving the input voltage to the inverting input, minus terminal. This is your inverting amplifier. This is your inverting. And this is also inverting. Whatever the output of this op-amp 1 is given to the input to the second op-amp, that is op-amp 2. Since this voltage is given to the inverting terminal, this is also inverting. This is also inverting. Again, this is your inverting. And whatever this value, like this, is plus terminal. Tell me, plus terminal means what? Suppose if I will modify this circuit like this, okay, the figure is like this. Okay, the output of the op-amp 1 is given to the input to the op-amp 2, output of the op-amp 2 is given to the input to the op-amp 3. You have to mark it. This is your op-amp 1 is inverting, this is your op-amp 2 is inverting also, because output of the op-amp 1 is given to the negative terminal of the second op-amp or inverting terminal, that's why it is also inverting op-amp, and output of the op-amp 2 is given to the non-inverting terminal of the op-amp 3. This is your non-inverter. Clearly the output of the op-amp 2 is given to the positive terminal of the third op-amp, so that's why it is a non-inverter. This is your non-inverter, non-inverting operational amplifier. Already you know, in case of op-amp, whatever the op-amp, in inverting case, V0 equal to what? Minus RF by RI. RF is nothing but feedback resistor, R1 is nothing but input resistor. In case of here RF, feedback resistor, means output of the op-amp 1 is given to the input of the input, that's why it is an feedback. It is also output is connected to the input, this is also feedback. So that's why this is your feedback. Here the gain A1, I can say A1, the gain of the op-amp 1, gain of op-amp 1. In gain of the op-amp 1, already I told you, in case of inverting amplifier, V0 equal to output voltage equal to minus this by this, RF by R1 into VI, which equal to feedback resistor value is how much? Minus 25 kilo ohm divided by R1 is your 5 kilo ohm. Kilo cancel. That is your minus 5 VI. V0 equal to minus 5 VI. Op-amp 1. That's why the output of the op-amp 1 equal how much? This is nothing but what? Minus 5 VI. Like this. V0 equal to minus 5 VI. Similarly, op-amp 2. In case of operational amplifier 2, this is also inverting amplifier. Let this is your V02. V02 is nothing but output of the second op-amp. V02 is the output of op-amp 2. This is your inverting amplifier. So V02 is how much? V02 value is how much? Minus RF by R1 minus, that is your 100 kilo ohm, divided by how much? That is your what? 25 kilo ohm into VI. VI value is how much? VI is your minus 5 VI into minus 5 VI here. So that is your 100 by 25, that is your 4. Minus plus. 4 into 5 VI. That is your what? 20 VI. So V02 is nothing but how much? 20 VI. The output of the second op-amp, that is your 20 into VI. Then come to the op-amp 3. In case of op-amp 3, this is a non-inverter. What is the non-inverter? Output of the non-inverter is how much? We have discussed. V0 is how much? 1 plus RF by R1 into VI. Is not it? RF is your feedback resistor here. Where is your feedback resistor in op-amp 3? This value is your feedback resistor. This is your RF. This is your RF. By R1 is how much here? That is your 50. So V0 value is how much here? V0 equal to 1 plus RF. RF value is how much? 150 by R1. R1 is your 50 into VI. What is your VI? Input voltage is how much here? Like this. V02 into V02 into V02. So that will be how much? 150 by 50 is your 3. That is 3 plus 1, 4 is your 4 V02. Okay. So V0 equal to 4 V02. So we already find out the output of the non-inverter, means output of the three combinational op-amp circuits. The V0 value is how much here? V0 equal to 4 V02. V0 equal to 4 V02. What is V02? Put the value here, 20 into VI in place of V02. The output of the last stage of the operational amplifier. There are three operational amplifiers as in cascade. Cascade means series. Output of the op-amp 1 is connected to the input of the second one. Output of the op-amp 2 is connected to the input of the third one. So that means 3 op-amp is connected in series, or 3 output of the one is connected to the input of the second one. Output of the second one is connected to the input of the third one. The 3 op-amp consist of 2. This is your inverting, this is your inverting, and this is your non-inverting. We are going to find out the gain, means output of the third op-amp V0 to the input of the first one. So V0 by VI. Our V0, final output V0 equal to 4 into V02. So output of the op-amp 3, that is your V0 equal to 4 into V02. So what is V02? Equal to 20 into VI. In place of V02, you can put 4 into 20 into VI. Okay, 20 into VI. V0 equal to 4 into V02, V0 equal to 20 into VI. We have to find out that is your V0 by VI. So V0 by VI is how much? 4 into 20. That is your 80. Okay. So gain V0 by VI, that is your 80. Okay. So that's why in this way you can find out the output of the operational amplifier. Suppose if there are 3 op-amp or maybe 4, suppose there is an inverter, there is an inverter, there is an non-inverter. If maybe it is your summer or adder, or it may be is your differentiator or integrator like this. In this way, you can find out the output of the each op-amp. First of all, you have to calculate the output of the each op-amp, then calculate the output voltage in terms of the input voltage to find the overall gain of the three-stage operational amplifier. Okay. It is also gain, that is your inverting operational amplifier, and there is an problems, that is your what? This is an clearly this is an inverting operational amplifier. Inverting means what? Giving input to the inverting terminal here. These are 25, 1, 1. V0 equal to minus 25 by 1, minus 25. Here minus 25 is your gain is given. That is your what? You have to design the inverting amplifier. Design, as far as design is concerned, you have to find out the value of resistance R1, what is the value of resistor R2 like this. Only the problem is, only the question is given the gain is minus 25. The gain is minus 25 is given, you have to design an inverting amplifier. To design the inverting operational amplifier, the two resistances is required, that one is your feedback resistor, another one is your input resistors. You have to find out, according to your gain, you have to design what will be the value of R1 and what will be the value of R2. Similarly, you can put the formula minus G25 gain is what? The gain you know that is your A equal to minus 25 is your what? Minus R1 by R2 here. Okay, minus minus cancel. So R1 by R2 equal to how much? So R1 by R2 equal to 25 or R1 equal to what? That is your 25 R2. So R1 equal to 25 R2. So according to your choice, if R2 is your 1 kilo ohm, then R1 must be 25 kilo ohm. If R2 equal to 2 kilo ohm, R1 may be 50 kilo ohm. So according to the value of R2, then R1 can be determined. As far as design is concerned, suppose one R1 resistance value is given, and you can easily find out the value of R2. If the gain is given, here my gain is minus 25. So in this way, the formula is, in case of inverting operational amplifier, the gain is your minus feedback resistor R1 by R2. In case of non-inverting case, the gain is your 1 plus R1 by R2. Thing is what? In non-inverting, the phase difference is 0 degree. In case of inverting, the phase difference is 180 degree. There will be negative signs at the output in case of inverting, because we are giving input to the inverting terminal, the minus terminal. But in case of non-inverting, we are giving the input to the plus terminal. That's why the output will get the plus sign. So then next, if I will say that is another application of the operational amplifier, summer or adder. Summer or adder. What does it mean? In case of inverting means what? Output voltage negative of the input voltage. V0 equal to minus of Vi. Non-inverting, V0 equal to plus of Vi. In case of summer or adder, actually the circuit is like this. In case of summer or adder, here non-inverting terminal in plus terminal is grounded here, and the number of resistors here this is your V0, let this is your V1, this is your V2, and this is your V3, and let this is your R1, this is your R2, and this is your R3. Okay. So in case of summer or adder, let this resistor, I can say this RF is your feedback resistor better. In feedback resistor, the resistor is connected from the output to the input, mark it as a feedback resistor. So that's why the output here, input is here, the output to input is connected to the feedback resistor RF. And the input resistance, there are three resistors are connected to the inverting terminal. Inverting terminal is your negative terminal. In case of adder, suppose I can mark it, let the current is I1 here, the current is your I2 here, and the current is your I3 here. Let this point, let I can say that is your V minus. So I can say this is your V minus terminal here. So what will be my output? If the number of resistors, more than one resistor are connected through different voltages to the inverting terminal, or that is your minus terminal. So only one thing is you should remember, in any type of problems related to the operational amplifier, KCL, the fundamental application, first of all you apply the Kirchhoff's current law. In case of a node analysis, you have to apply Kirchhoff's current law. Any type of problem you can solve it. So here this is a non-inverting terminal, grounded means what? This potential of a V minus must be 0. So apply Kirchhoff's current law here. Apply Kirchhoff's current law at where? This is a point law. Kirchhoff's current law is nothing but Kirchhoff's point law or Kirchhoff's junctions law. At this point and this point value is same. I can say V minus. Kirchhoff's current law at V minus. Look at this first. The current through the R1 is your I1. Current through R2 is your I2. Current through the R3 is your I3. Similarly, the current through the RF, I can say that is your IF. For better understanding, I can mark it as a notation feedback resistor RF and feedback current is your IF. So here, look at this here. These are the incoming current to this point. These are the incoming current. Clearly, this is also incoming current. The number of resistors are 3. Number of input voltages 3. And the current, obviously 3 currents, I1, I2 and I3, incoming to which point? That is your V minus. Similarly here, that is your outgoing current. This point and this point is the same potential, IF. These are the incoming current and these are the outgoing current. If you apply the Kirchhoff's current law at this point, so that is your I1 plus I2 plus I3, I1 plus I2 plus I3 equal how much? I1 plus I2 plus I3 equal to IF. This is the fundamental steps to find out the output voltage of operational amplifier. The basic step is to apply the Kirchhoff's current law in case of op-amp. So op-amp related problems you will find if you appear the GATE, graduate aptitude test in engineering, GATE IS on any type of competitive examination, engineering examinations, you will find definitely one question related to the op-amp will come. This op-amp chapter is for your basic electronics engineering courses, and it is one of the most important subjects, important chapters in basic electronics engineering. As far as op-amp is concerned, when you are going to solve the operational amplifier, first of all, first step, you have to apply the Kirchhoff's current law. And one thing is what? If this is your inverting terminal and this is your non-inverting terminals, and the non-inverting terminal is grounded, means what? Grounded means this is 0 volt. Due to virtual ground concept, in case of ideal operational amplifier, the gain is infinite. We are considering the gain is infinite, but the gain is very, very high, practical op-amp. So in ideal, all our assumptions is related to the ideal operational amplifier. In ideal operational amplifier, the gain is infinite and the output impedance is 0. That's why due to virtual ground concept, this difference voltage VD equal to 0. VD equal to 0 volt. If this is 0 volt, this potential is 0 volt. Potential at V minus is 0 volt. Then apply Kirchhoff's current law at this point V minus. Let I1 plus I2 plus I3 is how much? That is your IF. Tell me what is the value of I1? That is important. I current is nothing but what? Voltage by resistance. If it is I1 means what? That is your V1 minus this potential by this resistance. What is the value of I2? This potential minus this potential by R2. What is the current of this? This potential minus this potential by this resistance. So I1 value is how much? V1 minus this V minus by R1. In place of I1, I can write what? That is your V1 minus this potential, that is your V minus, divided by R1 plus. What is the value of I2? Here I2. This potential V2, this potential V minus. V2 minus V minus divided by R2 plus. Then what is the value of I3? That is your potential V3 minus V minus. V3 minus V minus divided by R3. This is the value of I1, I2 and I3. Is not it? Then equal to IF. IF is your feedback resistor. Tell me what is the value of IF? Current is your voltage by resistance. That is your what? This potential is what? V minus. This potential is your V0 because this is your feedback resistor, output and input. The resistance is connected from the output to the input. So the output, this is your what? V0 minus V minus divided by what? sorry, V minus V0 by Rf. This potential minus this potential is your V minus V0 divided by what? Rf. Okay. First of all, write the equations, apply Kirchhoff's current law at this point. I1 plus I2 plus I3 equal to IF. Put the value of I1, V1 minus V minus by R1. Then I2 equal to what? That is your V2 minus V minus by R2. What is I3? V3 minus V minus by R3 equal to this current is your V minus V0 by Rf. Then what is the potential of a V minus? It is important due to virtual ground concept. If it is 0 volt means this potential is 0. So this potential is 0 volt. This potential is 0 volt. This is 0, this is 0, and this is 0, and also this is 0. Okay. The expression will become what? That is your V1 by R1 plus V2 by R2 plus V3 by R3 equal to minus V0 by Rf. Okay. So V1 by R1 plus V2 by R2 plus V3 by R3 equal to minus V0 by Rf. Because due to virtual ground concept, if this potential is 0, this potential is 0, the potential at V minus will be 0. Then we are going to calculate the output voltage V0. So V0 is how much? V0 equal to, so V0 equal to minus of what? Rf by R1 into V1 plus Rf by R2 into V2 plus Rf by R3 into V3. Is not it? So V0 equal to what? Rf by R1 into V1, Rf by R2 into V2, Rf by R3 into V3. The minus is taking to the left side of the square bracket. This is the expression of, this is your expression of the output voltage of summer or adder. If Rf equal to R1 equal to R2 equal to R3, say if the value of the resistance value will be same, because this will be cancel out, this and this will be cancel out, this and this will be cancel out. So V0 value is how much? So V0 equal to minus of V1 plus V2 plus V3. Okay, what do you observe? The output voltage is nothing but the negative of the sum of the input voltages. The output voltage V0 equal to minus of sum of the input voltage. That's why op-amp is called as the summer or adder. Do you understand or not? If all the resistance value will be same, whatever the voltage of V1, V2 and V3, output voltage V0 equal to minus of V1, V2, V3. Suppose if I will say this is your 2 volt, this is your 3 volt and this is your 10 volt. What is my output? V0 equal to how much? Minus of 2 plus 3, 5 plus 10, 15 volt, minus 15 volt. Provided that what? The value of all resistor must be same. If the value of all the resistor will be same, then output voltage equal to what? Sum of the input voltages, that is your minus of V1, V2, V3. If I will connect then another 2 voltages V4, V5, the output voltage must be equal to the negative sum of the input voltages. That's why the op-amp is called as the summer or adder. One of the important applications of the operation amplifier is the summer or adder, because the output voltage is the negative of the sum of the input voltage. One thing is what? If the negative sign indicates that the input voltage and output voltage, there will be a phase difference of what? 180 degree. Why the negative sign will come? Because of we are applying the input voltages to the what? The inverting terminals, means negative terminal. That's why the output voltage, there will be a negative signs. Okay, thank you students. Then we will discuss more and more number of problems, then lecture 4 of the operation amplifier. Thank you.